Okay, my friends, here we are. Nice to be with you. We are on our second to last section. I know you might be asking yourself, when's he going to stop? Well, here we go. We have two left, 11.4, and then we'll finish up with 11.5. So this is our second to last homework and classwork videos for the school year. Hallelujah, in geometry. So let's go ahead and go out with a bang. We've got 11.4 inscribed angles. We have two definitions, inscribed angle and intercepted arc, and then a series of questions that will go to help you understand the concepts better, hopefully. So first thing is what this whole chapter is on is these ideas of inscribed angles. And so first, kind of a common sense definition is inscribed angle is an angle that comes from the side of a circle. So it comes from the side of a circle and extends to a chord, or basically intercepts the other side of the circle and then creates a chord. So angle E is an inscribed angle that intercepts chord DF. Intercepts chord DF. Okay, we had central angles a lesson ago where the angle came out from the middle of the circle, and we worked on those and found sector area and stuff, but now this is an inscribed angle. So we have angle on a circle, which means on the edge of a circle, that intercepts the side or chord or arc of the circle. That's how I'm going to define it. You can put what's in your book if you want. And so we have here again angle E intercepts arc DF. Okay, so it's an angle on the side of a circle or on a circle that intercepts the side or chord or arc, because you call this a chord or you can call this an arc of a circle. Okay, and so then our second definition, the intercepted arc, is simply I'm just going to say the part of a circle intercepted by an inscribed angle. Okay? And so this picture works for both of these, because here we have our inscribed angle, angle E is the inscribed angle, and then arc DF is the intercepted arc. And so that you just want that is your working vocabulary as you go through the exercises. Okay, part of a circle intercepted by an inscribed angle. So we're going to learn it through the first 4 questions, I think. Yeah, 4 questions. What are some cool things about inscribed angles to help us solve the problems of this lesson? Okay, so number 1 says, how does an inscribed angle compare to the arc it intercepts? So in other words, E and DF always have a certain relationship. And I've got just 3 examples of the same thing. And if you look in your book, is that the angle of the inscribed angle is always half of the intercepted arc. Or the intercepted arc is always twice as much as the inscribed angle. So for example here, if B is 36 degrees, AC as a percentage or as an arc from the center of the circle, in other words, if it came from just the very middle here, it would be twice as big, or 72 degrees. Or again, looking at the intercepted arc here, if this is 120 degrees, then angle E would be going in this direction, half of that. So E must be 60 degrees. Or just in terms of X, if the inscribed angle H is X degrees, then this intercepted arc must be 2X degrees. Okay, so we should probably put that into words. But the intercepted arc, not R, is twice the inscribed angle. So that'll be a quick and easy way in which you can solve and deduce information using inscribed arcs, or angles, I'm sorry. So another fun fact, which implies that, Number 2, what is true about all of the inscribed angles if they intercept the same arc? So here we have 3 inscribed angles, C, D, and E, red, green, and black. And they all intercept the same arc AB here. Well, just by thinking about if this is true, is that if each of these angles cover the same arc, then these must be the exact same angles. With question number 1, we know that AB would be 90 degrees. It's twice as big as the inscribed angle. So I know AB is 90 degrees, and I can see that C is 45. But therefore, if E and D, or any other inscribed angle that also hits that same swath of the circumference, the same, the distance between A and B, that means these all would have to be 45 as well. So these are all 45 degrees. So if you see two different inscribed angles, but they hit the same intercepted arc, and I could draw as many of these as I wanted to, if any inscribed angle that hits the same arc is all going to be equal. It's going to be half of that arc, but these will all be 45. Okay, so when the question asks what is true, it means they are all equal. We'll say congruent. Okay, so all inscribed angles, if they intercept the same arc, then they must all be congruent. Okay, so again, these are all, this must be 45, and this must be 45. Okay, all right, I'm going to switch to another piece of paper in order to cover the last couple questions. 3 and 4. What else can we learn about inscribed angles? Number 3 asks, what is the measure of an inscribed angle that intercepts half of a semicircle? So if we have inscribed angle C, and it's hitting, just assume this is half of our circle, passes through the radius, then what must be, what is true? What is the measure? Well, just remember what we've learned so far, that a semicircle, we learned in 11.3, or you already knew before that, how many degrees must this be? How much of the circle? How much of 360 is it? We know that arc AB is 180 degrees. So that means angle C must be, as we just talked about in question number 1, half of that. So number C must be 90 degrees, or a right angle. So that means C must be 90 degrees, or we could do this. Put that in there. I'll make this look a little better. A right angle or 90 degrees. So if it's half of a circle, then you already know, well, it's 180, and then the inscribed angle must be 90. Or, again, you can say, if I know this is 90, I know that I'm intercepting a semicircle, half of the circle. Okay? And then finally, number 4 says, what is true about the opposite angles of an inscribed quadrilateral? I know, you want to know this information, and so I'm so happy to teach it to you. But take any circle, and you can draw a 4-sided shape inside of it. Okay? And this is the one I drew. But there's a special relationship between opposite inscribed angles. And it comes from the fact that if you consider this. Let's look at X. Angle X intercepts this part of the circle, correct? Okay, so it intercepts that part of the circle. So that means, and if I look at the opposite angle Y, it intercepts this part of the circle. And so together, X and Y intercept the entire circle. That means they intercept all 360 degrees. So that tells me, it doesn't tell me what X and Y are, but it does tell me that together, that X plus Y must equal, again, if the outside arc is 360, then that means, and remember, these are half of it. Y is half of what it intercepts. X is half of what it intercepts. That means together they must be supplementary. They must add up to 180 degrees, sorry. Because any opposite angles in a quadrilateral will together be intercepting the entire circle. Same thing with Y. If I look at Y, Y intercepts everything here, and Z intercepts everything up here. So together, angle W plus angle Z must also equal 180 degrees. And of course that makes sense because all the angles inside a quadrilateral have to add up to 360. So just remember, opposite angles, I'm going to practice all of these with our final 4 questions. Opposite angles are supplementary. We'll put that word in there too. They add up to 180 degrees. Okay, so a couple things to keep in mind, and now let's practice those with these 4 questions. These are right out of the book, but I went ahead and drew them so I'd have something to reference while I went over them. But question number 2 asks us to find DEF. Okay, and that might be one of the hardest things about this lesson, is making sure you identify the correct angles and arcs that you're trying to find. So number 2 says angle DEF. So I'm trying to find this angle right here, DEF. And if this is your most basic kind of problem, because they tell us that this arc, DF, is 78. So if the arc is this, then we learn that the inscribed angle is half of that. So I just need to know what half of 78 is. If you do it off the top of your head, pull out your calculator. But 78 over 2 is equal to 39. Actually, I should go put my answers in red. Okay, 39 degrees equals, I'm just going to call it angle E, even though I know that's kind of cheating, DEF. So that's just half. So that's the most basic type of problem you want to be able to answer from inscribed angles. Okay, you have another problem where you're going to do on the homework. You have EG here, and so if F is 29, you can quickly know that EG is twice of that. So that's your typical use of our first the first thing we covered here. All right, number 6 then, a little trickier. You can see how this is going to get a little more complicated. But number 6 says find the angle of QTR. QTR. So we're trying to find this angle right here. Now, the reason this type of a question is a little more complicated is because I have no direct reference to QTR. Notice T is not necessarily a central angle, and this is not an inscribed angle. So even if I knew QR, I wouldn't know what QTR. But I can see they've created these triangles. So whenever you see that, you want to think, well, maybe I need to know some of the other angles, and then that's what will allow me to find this angle QTR. So let's look, and then you do that by saying, okay, well, what information did they give me? Well, what we can see is they gave us that angle S is 25. So that means out here, PQ must be twice that, 50. And then I can see that PQ is also intercepted by R right here. So that tells me I know what angle R is. Angle R must be 25 degrees. Must be also. So that angle R and angle S are congruent because, look, they intercept the same arc. Okay? Then I can say, oh, they told me this 90 down here. Why would they give me that? Well, if I know 90 SR, then that tells me, look at the arc or the inscribed angle that's intercepting that arc. Q must be half of 90. So now I know Q must be 45, half of the larger arc. So now look what I have. I know 2 angles of a triangle here. And the one I'm looking for, which again, I always mark up. I highly recommend you mark up your stuff so you can keep track of information. Doing this all in my head, at least not something I'm very good at. I can now know that this plus this plus this equals 180. So I know that my QTR, I know that 45 plus 25 plus, we'll just call it X, equals 180 degrees. So I can run that through my calculator. I can add those together. I can see that 180 degrees equals, let's see, that's 70 degrees plus X. And so what plus 70 is 180? I'll just jump to the chase. X is 111. I'm sorry, 110. 110. 110 plus 70 would give me the 180. So that means QTR is 110 degrees. And it looks pretty obtuse, so I like my answer. So notice you're going to have to use, we use several things there. We found angle Q because of what we knew over here. It's half. Then we used our second core idea that if you intercept the same arc, you have congruent inscribed angles. And then we had to use our good old triangle angle theorem to know what the 3 angles inside a triangle add up to. So there are going to be multiple steps to the more complex versions of questions you get in this lesson. But you can definitely reason your way to it, especially with a little bit of practice and help from yours truly. All right, then number 8. I'm going to apply another one of the concepts. Number 8 says find the value of y. So looking at this picture, I can see that FG is a diameter. It goes through the middle. That's why they put this circle here. It goes through the middle of the circle, so that immediately tells me what angle H is. Angle H must be 90 degrees. Because remember, if it intercepts half the circle, this would be 180. So that means this angle here is 90 degrees. Okay, notice they've also told me that I have two congruent sides. So that means this is an isosceles triangle and that this angle is congruent to this angle, which this is where all our knowledge of triangles for the whole year come in handy, which is why this is a great way to finish the year. That means that these angles are congruent. So that means this is another way you could this is a 45, 45, 90 triangle. Because this is 90, that means these two must add up to 90, and if they're congruent, they're each 45. So I know that this angle is 45 degrees. Hence, they've said find y. Well, now I can write an equation because I know what this angle is equal to. I can say 3y plus 6 equals 45. And then we can go ahead and solve algebraically. Minus 6 minus 6. 3y equals 39. We're going to divide by 3. Sorry, my work's kind of cramped in together. I had a lot of drawings to do. 39 divided by 3 is just y equals 13. Y equals 13. Okay? So notice we had to remember how 45, 45, 90 triangles worked so that we could know what this angle meant, and what triggered that was recognizing this is a semicircle with a diameter so that this angle had to be 90 degrees. Alrighty, and finally number 10. Number 10, notice it's a quadrilateral. It looks like kind of like a Star Destroyer. We have to find all of the angles. We have to find the angles P, Q, R, and S. So that means we probably need to solve for X. So what equation can I write in order to solve for X? Well, just remember, okay, what did they tell us about quadrilaterals? They said that opposite angles are supplementary, add up to 180. That's going to allow me to write an equation. I don't have anything for angle S, so I'm not going to use that. But P and R are opposite of each other. So that means, because notice, R intercepts this half of the circle, and P intercepts this half of the circle. So that means this plus this equals, that's right, 180 degrees. So 5x plus 20 equals 7x minus 8. Okay, we're going to go ahead and we'll subtract 5x on this side. I'm going to go a little faster because of the space. I'm running out of space here. I'm going to subtract the 5x on both sides, and I'm going to add the 8 to both sides. So we get, doing our good old algebra, looking ahead to Algebra 2 next year, 28 equals 2x. Therefore, if we divide by 2 on both sides, oh man, going to really run out of room. Let's put it right here. So that, therefore, x equals 14. So x is equal to 14. And so now, in order to find, now that's not your final answer, we asked us to find all four angles. So now it's just a matter of plugging it in. Plug in 14 for Q. I get 14 times 10. So that's 140. So angle Q is equal to 140 degrees. I know that angle S and angle Q add up to 180. So I can see that 140 plus S equals 180. So that tells me that angle S must be 40 degrees. Okay, because these two have to add up to 180. And then I can just plug 14 into 5x plus 20. That's a little much for me off the top of the head right this second. So 5 times 14 plus 20 equals 90. Okay, so angle P is equal to 90 degrees. And therefore, angle R, I can either plug it in, or I can see that, again, P and R have to add up to 180. So if P is 90, then R is also, 90 degrees. Whew, just squeezed it in there. Box it, because we can. All right, so we had to just apply the basic idea that they're supplementary. and that means they add up to 180. They add up to 180, and then we solved for the for x, and once we plugged x back in, we were able to find all 4 angles. Okay, let me just display both those sheets. And so we have homework 11.4. Again, a few problems to work through. You can see your reasoning can take a little bit of time, but just practice, get through the classwork, and please reach out for help. Had some good Zoom chats with some of you today. If you need any help, I'm here to do it. All right, that was our second to last homework of the year. Almost done. Stay strong and finish well.